Assalamu alaikum. I'm going to present my project ChainX QR-verifiable IoT blockchain platform for trusted supply chains. In this project, we have two platforms. First one is management panel platform and second one is maintenance panel platform. As we know that supply chain is a vast thing and there is a lot of gaps in this process, and we have tried to connect these gaps and loopholes to and make and made a platform that would connect this process from start to end. Suppose a person who wants a product from Japan, and product is maybe a beef, Japanese Wagyu beef, and he want to import this product to his country. First of all, he will come to our management panel and making and he will make a order to sender, and sender will start the shipment, and when he will confirm the shipment and it will complete it, update the status. Now I am going to demonstrate how he will do this. This is our project trajectory, and you can see that here is three terminal, and first one is for running the front end part, and the second one is for making a hard hat node and blockchain node. And when we write this command npx hard hat node, it will create a blockchain port in 127.0.0.18545, and it will automatically gives a demo 20 accounts for transactions. It is all from hard hat of Ethereum. Hard hat is a testing environment for blockchain locally. And then in third terminal, by giving this prompt, we have deployed the tracking in this frost id and contract address and ABI save to the context slash config.json. Here you can see all the details of transaction of blockchain and gas used how much and block created. This is the first block. After clicking the localhost link, we can see our part project. Here is our front end part project. In projects front end, first of all we have to connect the MetaMask wallet, and here I am giving my password for connecting the MetaMask wallet to our front end. After giving my password, I am logging in. After logging in MetaMask, we can see that here is our wallet, and it is connected to localhost 3000, and it is called GoChain testnet, and here is our account. By clicking this button, it will automatically connect to the wallet. First of all, sender will create a shipment, and for making a shipment we have to give the receiver address part and the pickup location, destination, and the distance of the total shipment. For the receiver address, we can take it from our MetaMask wallet from the other account, and other account is, suppose we take this account number 6 receiver address part and copy it and paste to the receiver address. and I am setting here a pickup location. Suppose it is Chittagong, and destination, suppose it is Japan, and destination is Chittagong, Bangladesh, and suppose the distance is 2000 kilometer, and we have set the price for the transaction is 0.000 ether. And when I click the create shipment button, and it will automatically invoke the, when I will confirm for the transaction using MetaMask, and it will automatically make the transaction. After, it will see my profile dashboard, and I can start from here the transaction. And after clicking the button, it will invoke again the MetaMask wallet and will automatically complete the transaction and making the shipment in transit. When it is in transit the product, our maintenance panel will do the another task, and when maintenance panel and shipment is completed and product is in the recipient's address, and when receiver will have the authority to complete the transaction, not the sender. And inside all the events I will explain in maintenance panel part. And suppose it is product received reaches to the receiver, and then receiver will complete the shipment. And for this we have to shift our account to the recipient address, and here is that. As you can see that I am transferring my account to recipient address, and the account is changed. And in this panel we are showing that that a complete button has raised here, and when we click the complete button, only then the shipment will be completed, and none other than that. And in status part you can see that it is in transit, and we can also search our shipment by our shipment ID, and here you can see that this is based on the shipment ID. And when receiver complete and click the complete button, and here you can see that MetaMask automatically invoked, and we have to confirm for the transaction. After confirming that transaction, you can see that action is vanished and status is completed. This is all from management part, and now we are going to the maintenance and tracking part. For management part, you can see that in our terminal, from the sender account to our register blockchain block, from this account to this account has successfully transaction, and every transaction is, you can see that successful, and you can see the everything.
Assalamu alaikum. Now I will describe about the hardware section of our project. In this section we use ESP32 as a microcontroller, then we use RFID, and then GPS, that is 6M Neo, and temperature sensor, that is DHT11. All the setup are include. This is the part of our smart container. All the sensors are under the smart container, and the GPS will get its latitude and longitude and then RFID will recognize when we need to when an authorized person wants to access the container, then he or she punch the card into the RFID, and then DHT11 is used for temperature collecting from the environment, and we use here servo motor as a actuator that open the door. If authorized person wants to access, then it will rotate 90-degree angle, and if unauthorized person will punch the card into the RFID, then it will not rotate. Here are four sections in our project. That is, in the input section we use the GPS, RFID and DHT11 as a sensor, and we use the environment, that is Arduino IDE. We upload the code from the Arduino IDE, then it's go to the ESP32. As in the, it is like a brain of the total system. Then it go to the there is a servo motor and also a buzzer. When if unauthorized person wants to access the RFID, then it will, there is a telegram alert section, then the camera, when it occurs, a Python script will automatically run and capture a picture, and then it will send to the of intruder, and then it sent to the telegram. Now I will demonstrate the whole project. Okay, it's our web page. In the web page we can see there is a temperature section. Here we can see the temperature that is already updated. Also a humidity section. In the, then we can see there is a GPS that is describe the latitude and longitude, and the last is card and in the GPS section we can see the latitude, longitude and the date. If we press the open in map, it will go to the map section, and then we can see our location. And all here we can see the session, that is last card and status. If we punch a card, then it will show, and all scan card list all the card that we punch here. Now I am scanning the card. Okay. Now I am scanning the card with my RFID. Here is the output. Here we can see I punch the authorized card. Then here we can see the access granted. And now I am scanning with the unauthorized card. The buzzer will running. Here we can see here we can hear the sound, and here we can see the access denied, that is the unauthorized card. Then in the telegram section, that we can see the telegram that takes my picture when I punch the unauthorized card. If the temperature is if the temperature rises with greater than with my threshold value, then it will send this alert.
Here, this is our product tracking code part, and as you can see that here in this terminal running backend part, front-end part and blockchain part as well. And I am going now I am going to front-end part. Here, this is our product tracking system of ChainX. This is also the named as the maintenance panel. As you can see that here admin is connected to the blockchain wallet in MetaMask. As you can see, now after management parts, sender to receiver data transportation, and it is happening when the product is in transit, and admin panel will control the flow. And first of all, admin panel will entry the sender certification number and then receiver certification number, and make the product ID basis of the management panel. Suppose I am taking a sender certification number as a demo, and it should be 8 to 10 digit as per code, and the receiver certification number and the product ID number is 0 for management panel. Now our product is ready to containerize, and after when it is containerized, it gets sealed, and then we can receive data from the container of RFID authorization and GPS location and DHT temperature and humidity data as well. I am adding the product now. Here you can see that the real-time sensor data from the ESP32 microcontroller, and here is the dashboard. You can see the GPS locations, you can see the environmental condition inside the container, and you can see the RFID access control, and everything here is there, and data is uploading here after 3 minutes. After loading the page, we can see that GPS is taking the data of longitude and latitude with date time, and suppose the uh, shipment is around completed, and it is the in front of the door of the warehouse consumer, the receiver part, and then the based of the GPS data, the admin panel will complete the product shipment. And as we can see that we can also click the IP address of the ESP32 and then see the monitor data panel also. And now I am completing the shipment. After clicking the complete shipment button, we have to interact with MetaMask and have to confirm the blockchain transaction. After confirming this, the product shipment is completed and QR code is generated here, and you can download the we can download the QR code for tracking the whole data. And here I am clicking the download QR code and close, and now I am seeing that the monitor panel, that the last and latest product ID is 0, certification number, receiver certification number, and status is completed. And if we click the QR code, we can see the QR code and also the pass data. If we click the QR code here, and it will give us QR code from the backend data. This QR code will help the retailer or the consumer to check whether the product is securely come from the sender's warehouse to the receiver warehouse or not, and it will help him to verify the product's authenticity, and it will enrich the traceability of the product. And our smart container system is giving the service and taking the liabilities to securing the whole transportation from the sender to the receiver, and make everything transparently and data driven by, and also monitor the inner situation of the condition by the temperature sensor and humidity sensor, and GPS location track the traceability, and the RFID make it tamper-proof, and whether unauthorized one is came here, it will take instantly a photo and send it to the telegram, and if temperature rises more than the fixed, then it will also send the notification or alert in the telegram. By the QR code, retailer or consumer will have the option to check the whole data that his product is, how came to on his hand, and how it is came, is it securely came or it is get tempered, and everything he will get by our this system. And here we can see that after scanning the QR code, we can see the product ID data and sender certification num, receiver certification num, and GPS data, and that are stored in blockchain. And here we can see the blockchain hash. And uh, back to the back to the product tracking system panel. We can go to the product verification part. After all of this process and the QR code generation, the consumer and retailer can check the data from our check and verify the data by our platform by product ID, blockchain hash, and transaction hash. By product ID, suppose we have successfully transaction or make shipment of product 0, and we can verify this, and after verifying this we can see the all history of data and GPS data, certification numbers, senders and receivers, and this data is stored in blockchain hash. We can see this by blockchain hash and transaction hash. Also we can search. Suppose a false product ID, maybe 989, that it is showcasing that product not found or not verified in blockchain. And in database part, we have used MongoDB database, and here you can see that our database, and here in database we have stored product ID and sender certification number, receiver certification number, and the status, and GPS data based on product IDs, sender, receiver certification number, and GPS data. It makes a hash by SHA-256, and this hash will store in blockchain, and blockchain will make a transaction hash. Here we can see that both hash, and that will also store in our database, and also the QR code also stores in our database. That's all of our database part. This is all from me about our exchange project. The project will helpful for sender, receiver, and the consumer or retailer, I think. For exporting or importing things, we know that everything we know that we have to rely on third party, and what a third party do inside the everything we don't know. And after all of the process, we have got our product, but using our system we can manage sender receiver portal part, and we are giving smart container and securing the whole thing, and it is also data driven. And for final retailer or consumer, I think it will very helpful, and uh, he will check that his data is tamper proof or not, and he will will also can be checked that his product is authentic or not, and he can trace when the data is in transit. And after all of this, he can also verify by checking the product ID or blockchain hash by our system. And all this data he, I think, will got from the QR code. And by all of these uh, he can rely on our system, rather than the regular system or regular container system or management system at all. Thank you.